Hello everyone. So today I wanted to go over a new build that I am undertaking. It's going to be a 2A3 HIFI amplifier. And my inspiration from this is the Inspire by Dennis Had as far as the layout and kind of tube complement here. So this amplifier that I have on the screen right now is Dennis Had's 45 amplifier, meant for the 45 power tube. It uses a 6SL7 and a Type 80 rectifier tube, which is the predecessor to the 5Y3 rectifier tube. So, I wanted to go for this very clean, simple, kind of like I have my 300B amp, and the 2A3 is kind of the little brother to the 300B. So, designing an amplifier, need to look at the data sheets for it. So I got the 45 here, which is what Dennis had used in his amplifiers. So in this sheet we can see the filament voltages, the current required for it, and some recommended specifications here. So let's hop over to the 2A3, and we'll see that it's 2.5 volts, just like the 45. Requires a little bit more filament current, 2.5 amps. So these are some specs you need to look at when selecting a power transformer, which I'll get into a bit later. And here is the recommended specifications for it. So filament voltage again, 2.5. Plate voltage, 250 volts max. Grid voltage of -40. Now, one thing to kind of keep in mind is whether you're going to be doing fixed biased or cathode biased. In my case, I'm doing cathode biased, which means that there's a resistor between the cathode of the tube and ground. And the way you get -45 volts on the grid is that everything is referenced to the cathode. So if the cathode is at plus 45 volts and the grid is at 0 relative to chassis ground, that means that there's -45 volts on the grid. So something else to look here is the load resistance, 2.5 kilo ohms. So need to look for a output transformer with about 2.5 kilo ohms. And speaking of that cathode resistor, otherwise known as self-biased, 750 ohms. So that takes a lot of the math out of it. But one easy way to figure out how they got that is again the 45 volts and 60 milliamps. Hop over to Ohm's Law calculator. So if we just go here and put in 45 volts and swap this over to milliamps, and we just toss in 60, 750 ohms at 2.7 watts. So the resistor needs to be over 3 watts, so a 5 watt resistor would be just fine. 750 ohms, that's how they came up with that value. We'll keep that calculation for a little bit later. So I want to hop over to the Type 80 tube. So this full wave rectifier need 5 volts for the filaments, 2 amps in the current, and have some limitations here based off of the milliamps that's going to be pulling. So I know because of this 60 milliamps, so need 2 of that, so that's 120, and then a little bit for the 6SL7. So we'd be looking right in here at 350 volts. And one thing that's nice is with a tube rectifier, you do get a drop in voltage. So they show here RMS per plate and the milliamps. And again, we'll be up in this line. So we can see about what we would need to get the correct voltage for it. So now let's look at the 6SL7 dual triode. This is the predecessor to like a 12AX7 or a 12AT7, right in and around there. 5751 is very close, modern equivalent. So here, let's look at the characteristics. 250 volts on the plate, grid voltage, and plate current. So again, this is referenced to the cathode, so it's really looking for 2 volts in the cathode, assuming that the grid does not have any voltage on it. Now with this, we also need to pick a plate resistor, because it's not going to be using an output transformer because it's not an output tube. The easiest way to figure out what plate resistor you need is to look at the plate resistance and double this. So 88 kiloohms. Now one thing we'll see is that there's what's called standard value resistors. So we just have to kind of pick the one that's closest to that, because I know 88K does not exist as a standard value. But what cathode resistor do we need? Well, we can do the same math that we did before. 2 volts, 2.3 milliamps. So do that. Oops. 2 volts and 2.3 milliamps. That comes up with about 870 ohms. Now a good rule of thumb is that you'll see that there's that kind of ratio of 88K, 880 ohms. A lot of times you'll see like 100K plate resistor, 1K cathode resistor. That ratio is pretty common amongst designs as a standard. So let's look first at transformers. None of these sites am I sponsored by. I just like to use them for certain things. So if we look at the transformers, let's look at the output transformer first, because it's going to be pretty easy. Now again, if you remember, we need an impedance of 2.5K. So this is going to be a budget amplifier. And one thing I do not like this style of output transformer where the leads are external to where little fingers can go and touch possibly 300, 400, 500 volts, because my chassis are open that I like. So those two are out. This one would be nice if you really are not on too much of a budget. It's 25 watt output transformer, which is overkill for a 2A3 tube, but it will allow a lot more lows to come through. I'm going to go with this one, a 10 watt output transformer. It was intended for guitar use, but it works just fine for hi-fi use because we're not going to be saturating it very much. And you can get it in different secondary impedances to match your speakers. I run 8 ohm speakers, so I'll be using 8. So for the power transformer, go here and go power, high voltage plate and filament. So if you remember, one of the oddities about the 2A3 tube is that it requires 2.5 volts for the filaments. So let's filter down by that first, and that will leave us with 4. Now one of the main differences between a lot of these is the high voltage here. So this one has the lowest voltage. So one easy way to figure out what the rectified voltage will be is to calculate this as if it were being done with a solid state rectifier. So if we look into here and look at the windings, we can see it's 300, 300, and then the center tap. So what we want to do is take the 300 and multiply it by 1.414. Now the 1.414 comes from the peak voltage calculation. So 300 volts is the RMS, or root mean square, which is the average voltage of the sine wave because it is AC. But when you convert it to DC and charge up a capacitor, you charge to the peak. So this will be 424 volts, and then there will be some droppage because of the rectifier tube. So I believe this will put us in the right spot. The other thing also to look at is that this has a 5 volt 2 amp for the rectifier tube, which is what we needed, and then 2.5 volts and 2.5 volts for the filaments of the tubes. So this is the one I'm going to go with. So now looking at some of the resistor values, 82K for the plates on the preamp tubes because 88 is not available, so that's the closest. You could go to 100 if you want to, but 88K. And then 820K is going to get us close to that 820 ohms is going to get us close to that 870 ohms that we calculated before. I generally use 1 watt carbon film resistors. Half watt would be just fine, but there is something called self-noise of a component. It will generate some noise by itself, and the higher the wattage rating, the less that self-noise is. So that's one good thing for us to look at. And then if we want to say use a 10 watt power resistor, they happen to have 750 ohms there. Another component we will need is what's called a grid leak resistor. So hanging off of the grid here, in order to keep it at 0 volts, you need a resistor. Now typically you'll see 220K is a very common value in there. But if you read in this data sheet some, when self-biased, cathode biased, so the resistance should not exceed 0.5 mega ohms or 500K, which 560 would be over it, so 470 is what we're going to use for that. And then you also need what's called grid stopper resistors. So, an example here, you need a resistor going into each part of the triode. Same here, but not going to ground. Now, one thing about those resistors to note is that the higher the value, the more stable an amplifier will be. However, you will be losing high end. So since this is a HIFI amplifier, I would like those to be as low a value as possible. And generally, 560 is a good place to be. That's what I commonly see and use in the HIFI amplifiers. So that gets us a good idea. I've got some parts to order for this. So if you like what you see and want to see this build come through, please like and subscribe. Thank you all.